In this video, I'm going to go over the 3 review questions for the free response for Unit 5 on integration. All right, so let's try this first one. So the first one says, the graph of a continuous function f is shown here. Let g be the function given by g of x equals the integral from -2 to x of f of t dt. So the first question, A, is asking me to find 2 values if I were to plug in certain numbers into x for that g of x function. So I'm going to do the integral from -2 to -6 of f of t dt. All right, now one thing I noticed when I plug this in is that my integral, my limits of integration, are not going from least to greatest. So I'm going to actually change this to be the integral from -6 to -2 of f of t dt. But you should know one of our property states that if you do this, then you need to find the opposite of whatever that value is, and that would give us the answer. So if I do this, then I'm looking at just -6 to -2, which in this case, -6 to -2 is just this triangle. So I can find that area under the curve. So my base is going to be 4 units. And then I have a height of 5. That's that y value there. And don't forget to multiply it by a half or divide it by 2 to give you 10 units. So that's for the first one. For the second part of this question, it asks for g of 3. So the integral from -2 to 3 of f of t dt. Now this one, when I plugged in that 3, my limits of integration are in order, right? It does go from least to greatest. So I'm going from -2 to +3. So -2 to 2, that's a semicircle. And then 2 to 3 is going to be a triangle. Now, one thing I noticed about that triangle, it is below the x-axis, so I will be subtracting that area. So in this case, when I find the area of that semicircle, right, the area of a circle is pi r squared. So for a semicircle, all I need to do is cut that in half. So it'd be a half of pi r squared. So the radius here is going to be that distance of 2 units. So I have pi times the radius squared. Don't forget to multiply that by a half. All right, and I'm going to put subtraction. You could put adding a negative, but I'm going to subtract this area of this triangle. So in this case, I have the base is just 1 unit, right? That's just 1. The height, even though I know it's going down, is 2 units. So 1 times 2 is 2, but don't forget to do half of that value for the base times height. So half of 2 is 1. So to make that an answer that looks nice, 2 squared is 4, half of that is 2, so 2 pi minus 1 is this answer. So my 2 answers were 10 for g of -6, and my answer for g of 3 was 2 pi minus 1. Okay, let's try one more question here for number 1. So part B says find g prime of 0. So again, this is one of those things where hopefully you remember the fundamental theorem of calculus part 1, which states that essentially derivatives and antiderivatives or integrals are inverse operations of each other. So if g of x right here is equal to an integral or antiderivative of a function, when I do g prime of x, essentially all I'm going to do is go back to that function f of x. So the idea is that if I'm backing up with the integral in terms of finding g of x, when I take the derivative of g of x, I end up with just this f of t, but we are plugging in x. So in this case, g prime of 0 is the same as plugging in f of 0. All right, so in this case, f of 0 is this point right here, which is 0, 2. All right, we'll talk more about that in class. All right, so that's it for the first one. Let's do number 2. Number 2 gives us a table where they're giving us w prime of t. All right, so again, when I see that derivative, I'm thinking a rate of change. It says in the question here that w of t models the volume of water in a reservoir at time t. So if I'm looking at w prime of t in my table, that would be the rate of change of the volume. I do notice that all of these values for my rates of change are positive, so we are going to have an increase in the volume of water over time. All right, so the first question says to find a left Riemann sum for this integral. So essentially, I'm going to first find the integral from 0 to 30 of w prime of t dt using a left Riemann sum, right? My intervals, they say, indicated by the data in the table. So my intervals are going to be 0 to 10, 10 to 22, and then 22 to 30. So what I'm going to first write down is all of my distances here are 0 to 10 is 10 times something, plus 10 to 22 is 12 times some value, plus 8 times some value. If you're wondering how I got those, I just took the values for, or the lengths of those intervals. Now, it does say a left Riemann sum. So when it says a left Riemann sum, I will be plugging in the left value of these. So again, I'm not plugging in, not putting 0 in these parentheses, or 0, 10, 22. I'm looking at my table and doing f of 0, or in this case, I guess I should say w prime of 0. W prime of 10 goes there, and W prime of 22. If this had asked for a right Riemann sum, exact same stuff, I would just be doing W prime of 10, W prime of 22, and W prime of 30. All right, so just know the difference between the left and the right. So W prime of 0 is 0.6, W prime of 10 is 0.7, W prime of 22 is 1.0. So if I were to get those values, I'm going to get 10 times 0.6, which is 6. 12 times 7 is 84, but you got to move the decimal to get 8.4. 8 times 1 is 8. So when you add those all up, you get 14.4 plus 8, which is 22.4 units. So let's go ahead and put a unit here. In this case, because we're doing the antiderivative of gigaliters per day, when I go backwards from that rate, I take out the per day part. So this is just 22.4 gigaliters, right? There's my units, GL. Okay, so that's the first part. Then it says, use this approximation to estimate the volume of water in gigaliters in the reservoir at time t equals 0. So again, I kind of told you this in this reservoir. So t equals 0, we're going to try to find some value. Okay, and then it tells us at time t equals 30, the reservoir contains 125 gigaliters of water. So t equals 30. You've got 125 gigaliters of water. But what we just found in our work was over this time, I'll use blue for the water, over this time, right, from t equals 0 to t equals 30, we have increased the amount of water in the reservoir by 22.4 gigaliters. So if we need to find our starting value or our initial value of volume of water in the reservoir, all I need to do is subtract 125 gigaliters minus 22.4, right? That's the amount that has been changed over that time. And that would give me my starting amount right here. So 125 minus 22.4 is going to be 102.6 gigaliters. That should be the starting amount here. So 102.6 gigaliters is our initial amount of water or volume of water in the reservoir. All right, so that's how you do number 2. Okay, let's go to the last one, number 3. Now, number 3 says we have a car traveling on a straight road, and it says for 0 to 24 in terms of t seconds, they give us the velocity modeled in this function. Find the integral from 0 to 24, and then using the correct units, explain what the meaning of that is. Again, so if we're finding the integral, right, that is the area under the curve from 0 to 24 of this velocity function. So essentially, this shape here, we're going to find the area, and I'm going to chop it up into different shapes. You don't have to use the exact shapes I'm using, because you could use like a trapezoid and a triangle, but I would imagine most students are going to avoid the trapezoid and just do a triangle, a rectangle, and then a third triangle. All of this is above the x-axis, so I don't need to worry about finding or any subtraction here. So 0 to 4 is going to be my first one, plus 4 to 16 let's use the correct notation here, Douglas. There you go. Plus 4 to 16. And then my last triangle is 16 to 24. So I'm really going to find three values here. So my first one is going to be 4, right? That base is 4. The height is 20. Height is 20. And then don't forget to divide that by 2 or multiply by half. Plus, this is just a rectangle. So 4 to 16 is 12 units. And then my height here, or width, is going to be 20 units. Plus my last triangle, my base is 16 to 24, which is 8 units. And then my height is 20 again. But don't forget to multiply it by a half or divide by 2. All right, so this first number is 80, but put that in half, you get 40. Plus 20 times 12 is 240. Plus we've got 80 times 2 is, or 8 times 20 is 160. Half of that is 80. So if you add those all up, you get, let's see, 280 plus 80 is 360. And again, since this is going backwards from meters per second, I'm going to be taking off that rate of change of per second and just writing meters. So that is it for the first part. Now the second part says, explain the meaning of this. So what we're saying is, right, if you remember all of our work in the first semester with PVA, right, this is our velocity, that's where we are right now. We are taking the antiderivative, so backing up to the position function. We are saying that the position of the car is changing by 360 meters in the first 24 seconds. So I'm going to say the car travels 360 meters from time t equals 0 to time t equals 24 seconds. All right, so that is it for the third question. And don't forget to come see me for office hours if you have any questions. Good luck on the test.